Thank you, Ahmed. Really appreciate you providing a terrific platform today and yesterday as well. And hi, everyone. So again, my name is Blake, and as Ahmed mentioned, I work at the Good Food Institute. And many of you will know that GFI is an entirely donor-funded nonprofit. And our goal, our reason for being, is to advance the market for alternatives to conventional animal products, namely alternative proteins, the name of this conference, of course. And so, as Ahmed mentioned, my role is really to conduct research throughout the industry, identify kind of bottlenecks and challenges that we face, and then work with everyone from kind of entrepreneurs to scientists and large corporations to develop technologies and companies that address gaps in the market. But we'll start out with just a bit more on GFI, and then we'll move on to the topic. And so GFI exists the world over. We have 100 plus staff in over 6 countries. We have 3 programmatic departments, again, as many of you know. Science and technology, where I reside. We have a corporate engagement team, and then a policy team as well. Now, for the purposes of today, and as well thinking more broadly about GFI, there are 2 things in particular that I think GFI does really well. And first off, that's thinking big, taking the big perspective on the industry, the big picture perspective. And then the second piece is focusing on the white space. And we're going to use these topics as the basis for our conversation as well. And obviously for this discussion, we're focusing specifically on cell ag. So that is cultivated meat, dairy as well. And then fermentation derived products. So let's start by thinking about the big picture. And I want to provide a bit of a window into the types of thinking that we do at GFI about the industry. So we can start out by kind of grounding ourselves in the universe that we are all operating in. This is a visual representation of total meat. And this is a concept, again, that we think a lot about at GFI. So this is the annual amount of animal meat that we are producing globally. And this is 350 million metric tons of animal meat. Now, just for some perspective, this is obviously the current conventional global meat industry, 350 million metric tons. This is the weight equivalent of 1 million VW Beetles, each weighs about a ton, produced each day. So it's a massive amount of essentially bioproducts that we're producing via this conventional meat production system. And of course, this is only going to continue to grow. This is a story that we talk a lot about, you know, what is the meat production system going to look like in 2050? But the unquestionable fact here is that the meat demand is only going to continue to rise. However, as a quick thought exercise, I want to consider what it might take to produce just 1% of total meat, 3.5 million metric tons, but do that via a cultivated meat production system, essentially using bioreactors. Now, this is a brief kind of back of the napkin estimate. This is using estimates and assumptions that are common in the industry. So let's consider, obviously, bioreactor is the medium in which we're growing, the environment in which we're growing the mammalian cells, the meat. So standard bioreactors, somewhere between 5,000 liters and 20,000 liters. Each bioreactor is producing somewhere in the neighborhood of 50 to 150 metric tons of meat per year. And that analysis, again, just a super high level analysis, shows us that we're going to need somewhere in the neighborhood of 20 to 50,000 bioreactors to, again, just produce 1% of the world's meat supply. And those familiar with really the capital outlays of bioreactors will immediately recognize the financial implications of these estimates, right? So it represents a massive opportunity for investors, as well as companies, right, to develop the canonical bioreactor for cultivated meat production. Even satisfying that 1% is a remarkable opportunity. And again, this is just a high-level thought exercise, but it is the types of thinking that we are weaving into the fabric of our work at GFI. Now, as well, I was going to kind of put the production of cultivated meat in the context of other bioproducts. So things like biofuels, amino acid, production, which is traditionally through fermentation, as well as biotherapeutics. Just in the interest of time, I'm going to move on. But with that said, if anyone out there is interested in having conversations about kind of how these comparable industries may shed light, insights, or implications on cultivated meat and other cell ag technologies, I'm always interested to have that conversation. But this is all to say that the question that we're asking at GFI, right, is how are we satisfying the global production volume of meat, right? These hundreds of millions of metric tons of meat via alternative means, via plants, of course, but for the purposes of our discussion, cultivated meat and fermentation-derived proteins. So we've sketched out just a little bit of kind of that big picture. And now I want to get specific and talk about white space. And at GFI, we identify white space essentially by systematically conducting research with people across the industry. And again, as I mentioned, this could be everyone from a bench scientist at a university all the way up through to, say, the CFO of a large plant-based meat company, and ask them, what are the key challenges in the industry, both from a technical and commercial standpoint, and what are potential solutions, what companies and technologies should exist but don't. And so to effectively kind of organize our thoughts around white space in the industry, and specifically when it comes to cell ag, we focus on the technology supply chain. And that in particular for cell ag is just because these technologies are a bit more nascent, there's a little bit less commercialization activity. So here, of course, this framework kind of outlines the key constituent technologies that go into both cultivated meat and fermentation-derived products. And I want to start out with cultivated meat. And obviously each constituent part of this value chain is essential, of course it is. But right now I want to focus on bioprocess design as a really important white space opportunity in cultivated meat. And it really is the key to ensuring that cultivated meat is a self-sustaining economic enterprise. And I want to sear that term into people's heads, because that is ultimately what is going to be critical if we're going to scale this industry. And in this instance, just as a brief note, when I say bioprocess design, I'm referring essentially to the bioreactors in which we're growing the cells. Obviously, there are other constituent components to the bioprocess design. Essentially, it's an end-to-end production process, but I'm really focusing on the bioreactor right now. So what is the white space when it comes to the bioreactor? What is the challenge? And really the challenge here is developing, again, economically viable systems for proliferation of cells and high density growth of cell biomass, essentially growth of meat in the bioreactor. And obviously there are multiple avenues, right, that we can attack this by. There are multiple potential solutions here to solve this challenge. I'm going to get a bit more technical and then I'll scope back out and talk about the broader concepts as well. But we can use things. One potential solution is using kind of existing process intensification techniques, many of which come from actually the chemical engineering space. So things like waste stream valorization, right? So can we convert byproducts of cells like ammonia and turn them into actual nutrients or media of cells, things like glutamine? Can we reduce shear forces on cells? So this is a big question as we're thinking about actually developing larger bioreactors. So as you develop larger bioreactors, that oftentimes exerts increasing force on cells, especially those at the bottom of the tank, which impacts cell viability. And then another example kind of for bioprocess optimization would be things like creating better outlets, say for CO2, which can lead to inhibition of cell growth and proliferation if we don't address that. There are also entirely new solutions that we can take to address this white space in bioprocess design. So these are things like, and again, thinking about analogous industries, right? So in the biotherapeutic space, increasingly, these companies are using plastic bioreactors to produce monoclonal antibodies. And obviously the big benefit of a plastic bioreactor, amongst others, is reduced capital expenditure. So again, inching us towards decreasing CapEx and increasing economic viability. Obviously, there are downsides as well to plastic bioreactors. Does that have implications on scale up and scale out for cultivated meat? And as well, does that impact things like sterility, et cetera? Nonetheless, it's an interesting line of inquiry. As well, there are alternative, completely new solutions, essentially alternatives to the conventional stirred tank bioreactor. things like 3D microenvironments. So this comes from the tissue engineering space and may allow for significant improvements in things like media diffusion, less shear stress, higher cell density, and potentially eliminating the need for seed train bioreactors, which is a massive contributor to capital expenditure in the cultivated meat bioprocess today. But all of that said, scoping back out now, what is the impact of focusing in on this one white space area in the value chain? The ultimate impact on creating better solutions for bioprocess design and cultivated meat, again, is decreasing CapEx and increasing the product yield or the cell mass, which ultimately, again, is going to allow us to create a more sustainable production process. Now, I want to move on in the interest of time to fermentation. And so this is an industry, an emerging industry, which we have a great deal of conviction in at GFI. And there are an abundance, obviously, of white spaces in this emerging tech category. And as well, we really do profit, right, from the development of fermentation in analogous industries. Earlier, I mentioned biofuels, amino acid enzyme production via microbial means, as well as a number of industries, brewing, of course, as well. But the upshot here is that these parallel developments in other industries allow us, at least ostensibly, to develop techno-economically sound production processes for fermentation as it relates to alt protein, and do so sooner than later. So it's really exciting, and we think there are opportunities along the entire value chain. I'm going to focus on a few specifics here, and then we'll wrap up. So as it pertains to the feedstocks, or essentially the carbohydrates that we are going to feed the microbes, this is a key input cost into fermentation. And there are really interesting concepts and work being done by a few fermentation companies. In particular, one comes to mind is 3F Bio's work. They are actually co-locating their production facility with a biofuels production facility, where essentially they're able to source cheaper feedstocks, cheaper inputs, because there's greater volume. And as well, they're able to route some of their waste streams that are coming from their fermentation-derived protein, their mycoprotein production process, route the waste streams into the biofuels facility. So it's actually a super efficient method, and we think that there are a ton of opportunities for co-location in the broader bioeconomy. As well, contract development and manufacturing is absolutely critical in places like the biotherapeutics industry. There are companies as well like Zymergen who operate in the synbio industry, right? And they allow you essentially to outsource certain parts of your R&D. So can you outsource as a company your upstream optimization of microbes, and you can focus potentially on more downstream measures, or vice versa. Maybe we have a contract development and manufacturing company in the fermentation space for all proteins that really focuses on developing large-scale manufacturing and bioprocess. And you as an in-house company can focus on the strain development. Last thing I'll mention here in fermentation is just, this is a story that's told quite frequently, and it should be, but we really do believe that the future of food is hybridized. And so obviously there are massive opportunities for developing fermentation-derived end products, things like, Impossible, the canonical example, Impossible's heme for plant-based meats, and as well thinking about ingredients for cultivated meat, things like growth factors, which likely will be produced via fermentation, via recombinant protein production. So there are abundance of opportunities here. But as we wrap up, I want to be really clear about our focus at GFI. And I'll start by saying that in a talk I was giving recently at the Industrializing Cell-Based Meats Conference, that was focusing exclusively on the consumer angle. And when it comes to the consumer, of course, taste reigns absolutely supreme. But from a production perspective, if we're thinking about creating an alternative production system that is going to feed the world, develop hundreds of millions of metric tons of meat in a new way, we have to be absolutely hell-bent on cost and on scale. And we think startups, we think the industry, academics, we think investors should all keep these two attributes in mind. And at GFI, right, when we're advising people across the industry on how to capitalize on white space in cell ag, we are encouraging them to keep these two attributes at top of mind. Ultimately, it's all about developing economically viable production systems at scale. So with that, that's all on my end. So my info is here. So feel free to reach out if you have any questions or if you want to spitball in the industry. That's what I do, and I absolutely love doing so. And then the last thing that I'll mention is that, just a quick plug, we do in the next few weeks plan to release our fermentation state of the industry report. So this we would really expect to be kind of the first comprehensive look at fermentation as it applies to all proteins. And that is penned by the terrific Liz Specht and Nate Crosser. They're my friends and my colleagues. So I'm really excited to see that be published broadly. And check out the link, gfi.org/industry, for an alert once that is actually released in mid-September. I'm going to pass it back to Ahmed, but thank you all for the time. Really enjoyed it.